Welcome to the Advantech Technical Training. In this opportunity, we will talk about the devices that are commonly found in the industrial field. The outline of this presentation will go through these main topics. First, field site devices, second, the devices in the factory, and finally the devices dedicated for automation. What is a field site device? A field device is a piece of technical equipment such as an actuator or sensor located in the field of measuring and control technology. They are the foundation of an automated process. The main task of these field devices is to transfer data on processes and machines for monitoring and analysis. Now we will introduce you the devices commonly found in the factory, such as local devices, metering, DC motor, surveillance cameras, and printers. A local device is usually a device attached directly to the computer rather than at some other point of the network, in which case they are called remote devices. When you plug in the scanner, the computer's operating system talks to the USB port to find out what was just plugged in. The barcode scanner has been pre-programmed to answer the PC that it's just another keyboard or a human interface device. When you scan a barcode, the data entry process is similar as if you just typed the characters on the keyboard. The barcode scanner has different specifications that make them very flexible to adapt to many applications. For the scanner type, it can be CCD, linear imager, laser, 1D 2D, RFID or NFC. The interface is the way to physically connect to the computer using ports such as RS-232, USB, Bluetooth, etc. Additionally, these local devices can support wide variety of operating systems such as Android, Windows and others. Barcode reader scanner range. The range has been divided into short, for a distance from 0 to 5 cm, middle range up to 40 cm, and long range up to 30 cm. CCD can only scan for 1D barcodes in short or contact range of scanning within 0 to 5 cm. Linear and laser can only read 1D barcodes, with mid-range of scanning within 3.5 to 42 cm. 2D imager scanners can read 1D, 2D barcodes with a long range within 4 to 31 cm. Barcode readers interfaces. Usually, the barcode readers have only one integrated interface. However, there are other versions that accept several interfaces using the same cable, like in the below picture. Simply, by cable changing and a reconfiguration of settings, and it can be used either RS-232, PS2, etc. The barcode scanners that use USB interface are devices of last generation. It is the most popular and most widely sold within barcode scanner. They send information faster than the previous ones such as PS2, RS-232, etc. It is USB powered, so no need for additional power. The PS2 barcode scanner interface is commonly called a keyboard wedge. It is used to older legacy POS systems that still utilize PS2 ports. For these devices, external power supply is usually not needed. The serial RS-232 barcode scanner interface uses COM-DB9 port, requires an external power supply. If the device uses serial RJ45, they may or may not require an external power supply. Usually only legacy and proprietary POS systems require a serial barcode scanner connection. Wireless barcode RF, and Bluetooth. They use a receiver which is connected to the computer equipment. The barcode reader is charged, either it has a base included with the reader or through USB cable. The two most common types are Bluetooth and radio frequency. The Bluetooth barcode reader is the most common type of wireless scanner. It can be paired with a smartphone or tablet device. For radio frequency barcode reader are ideal for scanning at a distance from the POS system or for warehouse inventory. Thermal printers. A printer is a device that accepts text and graphic output from a computer and transfers the information to paper. Like in the below animation, thermal transfer printers use a thermal printhead to transfer a solid ink from a ribbon onto the paper, polyester, nylon, or other thicker materials to produce a permanent print. Ribbon is usually made from wax, resin, or a combination of the two, and is bonded to the label supply surface with heat and pressure. The most common I/O interface for printers has been the parallel interface. However, the new printers use universal serial bus USB, or Wi-Fi. Smart meter devices. They are an electronic device that records consumption of a variable such as flow, energy, pressure, etc. and communicates the information in real time to the supplier with the purpose of monitoring and billing. The advantages of using these kind of devices are: saving of energy, detection of issues with the abnormal consumption, monitor and control delivery and manage billing history and data. This application scenario is focused on a gas monitoring solution. This kind of solution is suitable for gas supply enterprises to monitor gas metering remotely. In the monitoring center, the gas dispatching personnel can monitor the gas supply situation of the whole city, supply the gas efficiently and ensure a safety gas delivery. With these kind of solutions, it is easier to find and forecast the tube explosion accident in real time. In addition, this scenario also can expand the functions on gas leakage monitoring and valve remote control. Actuators. An actuator is a component of a machine that is responsible for moving and controlling a mechanism or system, for example a motor, valve, cylinder, pump and switches. When the actuator receives a control signal, it responds by converting the signal into mechanical motion. An actuator requires a control signal and a source of energy that is usually electric current for motors, hydraulic fluid pressure for cylinders, or pneumatic pressure for valves. Electronic actuators. This application scenario is related to the motion, position and control for the motors. In the industry, most companies adopt a PC-based controlled system. In this structure, the PCI card interacts with the PC. The PCI sends commands to the servo driver, which sends the current to move the motor. At the same time, the servo driver takes the feedback signals from the encoder sensor, then it can correct the point and reach the predefined position. In short, the servo driver takes advantage of closed-loop control to manage the servo motor to reach the predefined position accurately. Surveillance cameras. These devices are used for the purpose of observing an area. They are often connected to a recording device, DVR or IP network. PoE/IP cameras, namely Power over Ethernet cameras, get the power and transmit videos using only over one Ethernet cable, so no extra power is needed. Surveillance IP cameras. The limitations of conventional cameras are distance and environment, which distorts and causes loss of images. To reduce the problem of noise, customers have changed from digital CCTV to IP cameras. IP cameras are nowadays accepted in the security industry. The advantages are reliability and flexibility in the video transfer. Cost reduction, since there is no more complex electrical wiring. Industrial cameras are commonly referred to as machine vision cameras, as they are used on manufacturing processes for inspection or quality control. Machine vision uses sensors, cameras, processing hardware and software algorithms, to automate complex tasks. Visual inspection and quality control, precisely guide handling equipment during product assembly or any industrial process. Digital industrial cameras are generally more robust than the standard digital cameras used for vacation snapshots. The image quality in industrial cameras is often higher than that found on a normal camera, since highly detailed images are frequently required for specialized measurement tasks. Machine vision uses sensors, cameras, processing hardware and software algorithms to automate complex tasks. Visual inspection and quality control, precisely guide handling equipment during product assembly or any industrial process. Automatic paper inspection. Traditionally, the manufacturing process has a human element at the inspection stage, where products are being visually inspected. An automatic solution has been offered to the customer with the possibility to integrate the industrial cameras, illumination and optics to capture a high-quality image of the product. By this way, the system uses computer visual technology for real-time quality control, to automatically check parts for many different defects, for example, contamination, scratches, dents, or deformations caused by faults in production. Smart parking helps one of the biggest problems on driving in urban areas, finding empty parking spaces and controlling illegal parking. Smart parking systems obtains information about available parking spots in a particular area. It involves using low-cost sensors and real-time data collection. By this mean, Smart parking reduces car emissions in urban centers by reducing the need for people to needlessly circle city blocks searching for parking. It also permits cities to carefully manage their parking supply. Thank you for listening the first part of this training video. You are welcome to continue to listen the next part in the following video. Welcome again to the Advantech Technical Training. We will continue with the second part of the Common Field Site Device Introduction. Now, we will introduce you the devices that are more commonly used in automation fields such as electrical and control cabinets, PLC, HMI, power generation, controllers CNC. The electrical cabinet. It has the function of support for mounting electrical or electronic equipment such as switches, measurement elements, displays, etc. Protect the contents from the environment such as water, dust, corrosion, etc. Prevent electrical shock to the operators during their work. The electrical cabinets are manufactured with different materials: stainless steel, aluminum, polycarbonate, fiberglass. Its performance is based on the IEC 60529 standard that classifies the ingress protection rating, IP codes, of this cabinets. This standard IEC 60529 classifies the degrees of protection provided against the intrusion of solid objects and water in electrical cabinets. The standard aims to provide users more detailed information than vague marketing terms such as waterproof. Ratings are defined by the letters IP followed by 2 digits. The first digit is related to the protection against ingress of solids. The number indicates conformity with the conditions summarized in the tables below. For instance, the number 0 means there is no protection, and the number 6 means protection against the ingress of dust height. For example, an electrical cabinet rated with IP2X is protected against a solid greater 12.5 mm diameter, which can be fingers and they will not be damaged. The second digit is related to the protection against ingress of water. The number indicate conformity with the conditions summarized in the table below. Thus, the number 0 means there is no protection, and the number 7 means protection against submersion at 1 meter depth. For example, a cellular phone rated at IP67 is dust resistant and can be immersed in 1 meters of water for up to 30 minutes. Electrical control panels are designed for mounting control mechanical equipment. Usually the design of a cabinet starts with 1. Incoming protection and switching, 2. Power and energy monitoring and control, 3. Power distribution system, 4. Thermal management, 5. Motion and drivers, 6. Circuit and load protection, 7. Motor control, 8. Enclosures, 9. Power supplies and transformers, 10. Programmable controllers, 11. Operator dialog, 12. Interface and I/O, 13. Machine safety, 14. Relays. External elements of an electrical cabinet. 1. HMI panels is a graphical interface that allows information exchange and communication between machines and the operator. 2. A push-button switch allows to turn on and off a machine. When it's on, a small metal spring inside makes contact with 2 wires, allowing electricity to flow. 3. Maintained push buttons. They require to be pushed once and can keep the stay until is pushed them. 4. Emergency stop switch is a safety mechanism used to shut off machinery in an emergency situation. 5. Tower lights shows the state of a process, alerting that some process happening. Internal elements of an electrical cabinet. Inside a cabinet can be found several electrical devices. Some of them are introduced as follows. 1. Transformers. They are used to convert one AC voltage to another AC voltage. Most popularly would be converting 480 volts AC to 120 volts AC for creating control power. 2. Programmable logic controller PLC is the brain of the control panel. It reads inputs and trigger outputs, then adjusts the outputs of the control panel. 3. DC power supply converts AC or DC to a DC voltage. Most commonly converts 120 volts AC to 24 volts DC. 4. Ethernet switch is used for connecting the devices such as PLCs, HMIs and integrate them into the same network. 5. Circuit breaker, protects loads from pulling too much current and helps to prevent possible damage to the whole system. 6. Disconnect switch, it will usually disconnect all electrical power from the control panel. 7. Wire duct, is usually ran around the perimeter of the panel and in between rows of electrical components. Wire duct, house the wires that interconnect the electrical components. 8. Terminal blocks, are connection points to tie wires together. Some are for internal connections and some are for connecting field components to terminal blocks. 9. Breakout boards, are specialized terminal blocks that can be used to simplify wiring of components that have connectors that would normally need soldering. 10. Fuses, are like circuit breakers and protect loads from pulling too much current but, are only good for one use, cannot be reused. 11. Relays is an electronically or magnetically operated switch. Power is applied to the coil, and it switches the relay contacts. As a result, the contact that was open at the beginning will change the status, and turn to be closed. 12. DIN rail, is a metal rail that allows the mounting of many industrial control components. 13. Overload, protects loads, usually motors, from pulling more current than expected. 14. Contactor is the same as a relay but is usually larger in size and used for a 3-phases motor. An application of this is a motor starter, which helps to switch the power automatically or manually to a motor and at the same time protect the motor from overload or faults. A programmable logic controller, PLC, is a computer designed to work in an industrial environment. It continuously monitors the status of devices connected as inputs. Based upon a user-written program, stored in the memory, it controls the status of the devices connected in the output. PLCs are used in many machines, in many industries. Typically employed in industrial electromechanical processes, such as control of machinery on factory assembly lines, amusement rides, or light fixtures. The PLC mainly has 5 parts: input module, output module, CPU, and power supply. The primary function of a PLC's input circuitry is to convert the signals provided by these various switches and sensors into logic signals that can be used by the CPU. The CPU evaluates the status of inputs, outputs, and other variables as it executes a stored program. The CPU then sends signals to update the status of outputs. This picture shows a very typical application architecture in a smart oil field. In the PLC, inputs will have connected sensors such as thermometers, flowmeters, pressure sensors, and etc. In the PLC outputs, it will have connected lights, electric valves, motors, and other actuators. The PLC reads the inputs and evaluates these values in the program that is stored inside of the CPU, then the PLC updates the status of the outputs. At the final, all of the information can be transferred remotely to the control room where it is monitored and analyzed. Day by day, many companies are leading to advanced technologies in the development of new controllers PLC. Every company will provide various and different functions and features. The most famous PLC brands around the world are Allen-Bradley, Schneider, Mitsubishi, Omron, Siemens, Bosch, ABB, Hitachi, Honeywell, Delta, Fake, and General Electric. According to the application, we can find PLC dedicated for basic applications with smart relays such as Siemens Logo Series, Schneider's Helio Series, and Omron Zen Series. For simple machines application, we can find Delta DVP Series, Schneider Twido Series, Siemens S7 Series, and Allen-Bradley Micrologics. On the other hand, for more complex applications with middle number of inputs and outputs, we can find controllers such as Schneider M340 Series, Siemens S7 Series, and Allen-Bradley Compact Logic Series. Finally, for critical applications that requires high number of inputs and outputs and redundancy, we can find Schneider Premium Series and Siemens S7 400 Series. Another important device within an automated system is the HMI, that states for human-machine interface. Before the HMI came into existence, a control might consist of hundreds of push buttons and LEDs performing different operations. HMI is a device for user interface or dashboard that connects the operator with the whole system. The HMI provides a visual representation of a control system and provides real-time data acquisition. It is a centralized control center that is user-friendly. It is suitable for applications that require constant feedback and monitoring. In the first picture, it shows an application where the HMI is installed on a cabinet. The pre-assembled seals allow high IP protection against water and dust without big effort. In this way, the panel can be manipulated without a risk of damage. In the second picture is the installation seen from inside of the cabinet. The system as a whole can then be fixed with 8 screws from the inside or with clamping screws versus the front panel. This design type features extreme robustness and is particularly suitable for quick installation. This is an application of a manufacturing line monitoring system, which allows the operators to monitor everything on the factory from a centralized room. The Industry 4.0 solution enables operators to acquire data at different stages and stations of production. In this application, every station contains different sensors such as switches, light towels, and analog signals. The PLC takes all this information from the sensors and transforms it to digital signal, so the HMI can decipher, make decisions and show the results on the screen. The advantage of developing a smart factory is that operators can predict machine failures and brings higher operational intelligence. Finally, it is possible to connect multiple production lines and machines with each other. Now, we will give a general concept of electricity. Electricity is nothing but the movement of electrons through a conductor, like a wire. In the below picture you can see how does the electricity flows in 2 ways, either in direct current, DC, or in an alternating current, AC. The difference between AC and DC lies in the direction in which the electrons flow. In DC, the electrons flow in a single direction, or forward. In AC, electrons switch directions, sometimes going forward and then going backward. The advantage of using alternating current AC is that it can transmit electricity over large distances such as for household use. Converter and inverter are 2 concepts that are easily confused, however we will make a comparison between the 2. The converter is an electrical device that converts the voltage from alternating current, AC, to direct current, DC. The converters are a fundamental part of most of the electronic devices. The inverter does the opposite work. It converts the voltage from direct current, DC, to alternating current, AC. The below application starts with the solar panels collecting the light from the sun. The circuit of the solar panel is coupled to the inverter that converts the DC current into AC. Later this energy can be used in a house to turn on the light. Now we will also explain the difference between a motor and a generator. The motor converts electrical energy into mechanical energy. For this, it uses electricity to work. The motors are used for pumping water, automotive, conveyors and lifting. In the below application the motor is coupled to a pump to extract the water from the river, and provide the house with water. On the other hand, a generator converts mechanical energy to electrical energy. Thus, this device generates electricity. They are usually used for applications where there is a lack of energy. In the below application, the garage may be located far from the house and with no electric installations. The portable generation can be employed to turn on the motors, and open the doors and let the car get inside. Combination of AC motor with inverter. Homes, office buildings, and factories are supplied with AC electricity at various frequencies and voltages such as 50 Hz and 60 Hz. But AC motors are constant speed devices. So, how can we modify the motor's speed according to our applications? In the electrical field, we can take advantage of the inverter. It will change the input voltage or frequency which directly modifies the motor's rotation. Without an inverter, the AC motor would operate at full speed as soon as the power supply was turned on. With no change of speed, applications would be limited. This type of control, in which the frequency and voltage are freely set, is called pulse width modulation, or PWM. The inverter first converts the input AC power to DC power. The second step, the inverter creates a new AC power using PWM control. At the final, the inverter provides to the motor a controlled power that suits any application. Finally, we will talk about the controllers CNC because nowadays are widely spread in the industry. CNC machining is a process used in the manufacturing sector that involves the use of computers to control machines' tools such as lathes, mills, routers and grinders. The physical movements of the machine are controlled by instructions, such as coordinate positions that are generated using a computer. CNC is typically used to refer to a device that uses a rotating cutting tool that moves in 3 or more axes, X, Y and Z, to cut out or carve parts in different types of materials. The advantages of using a CNC are high repeatability and precision, high volume of production, machining of complex contour surfaces, more safe, higher productivity with higher quality. But it also has some disadvantages such as costly setup, and difficult maintenance requirement of hiring skilled operators to program the computers. Here, we introduce the most representative CNC machines. Milling, the most widely used CNC machine, predominantly for drilling and turning metals. Lathes, for production of 3D shapes or molds. Routers, used for cutting complex or intricate shapes and prototypes. Plasma and laser cutters, utilized for cutting 2D shapes and molds. Web Access CNC Advantech solution. With the evolution of industrial automation, machines nowadays are becoming smarter and more digitized. To accelerate the implementation of smart machine monitoring and management in Industry 4.0 applications, Advantech's CNC machine management solution plays a critical role in IoT integration from edge computing to cloud-based services. A solution of this type starts connecting the instrumented module and equipment that is located in the field site. Later the information is transferred to the WisePass cloud service using the edge devices that work as a gateway. As a result, Advantech offers an intelligent CNC management solution that has been developed to bridge the gap from traditional machine management to optimization. Thanks for your attention. Hope this course gave you a basic concept of common field site device. If you are interested in advanced concepts and hands-on, please join our product training courses. You will get a return with fruitful knowledge and skills. See you next time. Have a good learning day.